We're just days away from Starship's ninth flight, but it looks like SpaceX is still facing a few notable challenges. So, the big question is, when exactly will liftoff happen? Over at SpaceX's Roberts Road facility in Florida, things are moving fast, catching up with the rapid-fire pace we're seeing at Starbase. And here's the exciting part. SpaceX is close to completing its very first Starship orbital launch pad in the state. Could Florida soon become the main launch hub for future deep space missions? It's looking more and more likely. And here's something even more surprising. Voyager 1, the oldest active spacecraft in history, is still sending signals back to Earth. But just how far away is it now? On space. Now, we're bringing you the untold story of this legendary space probe that just woke up after nearly half a century. Are you ready to unlock the secrets of deep space with us? Starship is rapidly approaching a defining moment. Flight 9 is finally within sight. Have you ever seen the space community this anxious before a test launch? Let's take a quick trip down memory lane. The last time the anticipation was this high was during the early suborbital campaigns, especially when SN11 vanished into the thick Starbase fog. Remember that gut punch feeling? We recently ran a community poll on Flight 9, and the results were eye-opening. Over 5,800 votes were cast at the time of this recording. 67% believe this flight will be a success, with Ship 35 making a smooth splashdown in the ocean as planned. Only 18% fear a premature explosion like what we saw in Flights 7 or 8. The optimism is real, and it's rising. Of course, we can't ignore a key piece of the puzzle. The FAA has already approved license modifications for Flight 9, allowing SpaceX to increase annual launch frequency at Starbase from 5 to 25. But here's the catch. Flight 9 still can't launch unless the FAA wraps up its investigation into the Flight 8 mishap and reissues a flight clearance. That means even if Starship is fully stacked on the pad, the final go has to come from the FAA. Do you think this oversight process is essential for safety, or is it holding back innovation? To maximize safety, the launch exclusion zones, both maritime and airspace, have been expanded. This marks the first time SpaceX will reuse a previously flown Super Heavy booster, a historic step in its journey toward full reusability. Maritime alerts NOTAMs and MARADs have now been extended into early June. This also signals the heightened risk level as flight systems and safety protocols continue to be fine-tuned in real time. Important note: when it comes to any heavy-lift launch system or military-grade launch vehicles, sea safety isn't just a checklist item. It's a cornerstone of responsible operation. That's why most launch sites are built along coastlines far from densely populated areas. Even though SpaceX has completed all the physical milestones, rocket assembly, launch pad construction, engine testing, it's the paperwork barriers that remain unpredictable. Regulatory delays can leave everything in limbo, even when the hardware is ready to fly. Starbase isn't just a launch site, it's one link in a broader operational ecosystem governed by federal agencies. Do you think the approval process should be streamlined and digitized in this high-tech era? While we wait, Booster 14-2 has been rolled back to the engineering area for further inspections, even though it was already mounted on the launch pad. No official reason has been given, but clearly there's a potential issue. The latest maritime advisories also confirm that the launch can't take place before May 26th. And with SpaceX unable to close public beach access over Memorial Day weekend, the earliest realistic launch date is May 27th. Meanwhile, Ship 35 is still undergoing final checkouts inside Megabay 2. Recent static fire tests have been completed, but there are rumors that a few engines are being replaced. If that's true, SpaceX might need to conduct another full engine test. What does that tell us? that they're being extremely cautious, and that's a good sign. Do you believe engine reliability is the key to sending humans to Mars? Flight 9 isn't just another test, it's a critical step toward full reusability, especially with SpaceX preparing for its first-ever attempt at a ship catch using the robotic chopsticks arms. It's one of the most complex maneuvers in the entire Starship program. Pulling it off will require vast amounts of real-world data to fine-tune landing dynamics and account for unexpected edge cases. If successful, this would pave the way for satellite and cargo missions, an essential element of Starship's commercial future. And there's even more pressure coming from the Mars plan. Elon Musk has hinted that an updated roadmap for sending humans to the Red Planet will be shared before Flight 9. But what's the next viable golden launch window for that mission? Experts are debating this, as Starship still has a long road ahead before it's ready. The launch window to Mars only opens once every 26 months. Miss it, and you wait nearly 2 more years. Do you think SpaceX will be ready in time? On space, now we're tracking the breakthroughs from NASA and SpaceX as they push space science beyond what anyone thought possible. Personally, I believe they will pull it off. All it takes is one fully operational Starship. The timeline may have shifted more than once, but the ultimate goal, reaching Mars, has never wavered from the heart of SpaceX's mission. And nothing is more inspiring than seeing the entire space community come together in anticipation of Flight 9, like we are now. But all eyes are also beginning to turn toward a new name, Block 3. That's the real game changer. If Block 2 introduced improvements in structure and avionics, Block 3 will take things to the next level with a taller vehicle, larger fuel tanks, and a full suite of upgraded Raptor 3 engines. Even though SpaceX has completed all the physical milestones, rocket assembly, launch pad construction, engine testing, it's the paperwork barriers that remain unpredictable. Regulatory delays can leave everything in limbo, even when the hardware is ready to fly. Starbase isn't just a launch site, it's one link in a broader operational ecosystem governed by federal agencies. Do you think the approval process should be streamlined and digitized in this high-tech era? While we wait, Booster 14-2 has been rolled back to the engineering area for further inspections, even though it was already mounted on the launch pad. No official reason has been given, but clearly there's a potential issue. The latest maritime advisories also confirm that the launch can't take place before May 26th. And with SpaceX unable to close public beach access over Memorial Day weekend, the earliest realistic launch date is May 27th. Meanwhile, Ship 35 is still undergoing final checkouts inside Mega Bay 2. Recent static fire tests have been completed, but there are rumors that a few engines are being replaced. If that's true, SpaceX might need to conduct another full engine test. What does that tell us? That they're being extremely cautious, and that's a good sign. Do you believe engine reliability is the key to sending humans to Mars? Flight 9 isn't just another test, it's a critical step toward full reusability, especially with SpaceX preparing for its first-ever attempt at a ship catch using the robotic chopsticks arms. It's one of the most complex maneuvers in the entire Starship program. Pulling it off will require vast amounts of real-world data to fine-tune landing dynamics and account for unexpected edge cases. If successful, this would pave the way for satellite and cargo missions, an essential element of Starship's commercial future. And there's even more pressure coming from the Mars plan. Elon Musk has hinted that an updated roadmap for sending humans to the Red Planet will be shared before Flight 9. But what's the next viable golden launch window for that mission? Experts are debating this, as Starship still has a long road ahead before it's ready. The launch window to Mars only opens once every 26 months. Miss it, and you wait nearly 2 more years. Do you think SpaceX will be ready in time? on space. Now we're tracking the breakthroughs from NASA and SpaceX as they push space science beyond what anyone thought possible. Personally, I believe they will pull it off. All it takes is one fully operational Starship. The timeline may have shifted more than once, but the ultimate goal, reaching Mars, has never wavered from the heart of SpaceX's mission. And nothing is more inspiring than seeing the entire space community come together in anticipation of Flight 9 like we are now. But all eyes are also beginning to turn toward a new name, Block 3. That's the real game changer. If Block 2 introduced improvements in structure and avionics, Block 3 will take things to the next level with a taller vehicle, larger fuel tanks, and a full suite of upgraded Raptor 3 engines. Did you know Raptor 3 is the most advanced full-flow staged combustion engine ever built, with a combustion chamber pressure that surpasses even Russia's RD-180? The first signs of change have already appeared at the production site, a new heat-resistant tile system and metallic thermal shielding now installed on ships like TT-17, Ship 39, and Ship 40, all believed to be part of the Block 3 lineup. Don't underestimate those tiles. They could be the missing piece that allows Starship to be reused without needing a new heat shield after every flight. Are you ready to explore the Raptor 3 engine, the future of SpaceX, and a revolution in space exploration with Space Now? There's a lot of buzz around the upcoming Block 3 variant of Starship, which is expected to outperform Block 2 in nearly every aspect, from thermal protection to reusability and flight stability. Will it live up to the hype? We're about to find out. Even though the launch timeline keeps slipping, progress at Starbase hasn't slowed down for a single day. Recently, a new orbital launch mount OLM was positioned atop the flame diverter system, securely resting on 4 massive support pillars. Just lifting it into place was an engineering feat requiring SpaceX's 2 largest cranes to operate on the very edge of the flame trench and rotate the structure with pinpoint precision. Fun fact: installations like this aren't just about coordination. They're real-world stress tests for the structural design of the entire launch platform. One minor error could delay the project by months. Looking closely beneath the new OLM, welding work has been happening non-stop, suggesting the structure is being permanently affixed to the concrete foundation rather than bolted down as many had assumed. That means Pad B won't be able to quickly swap out launch mounts as once expected. It's a bold move by SpaceX, clearly prioritizing structural rigidity to handle high-risk launches. What do you think? Should the focus be on flexibility for easier maintenance or maximizing stability by locking the system in place? Over the weekend, the Magic Chopsticks, technically known as the Mechazilla arms, underwent a pretty unconventional test. Instead of using heavy blocks of concrete or steel, SpaceX suspended 4 massive water bags from the chopsticks to test their load-bearing capabilities. This method, called using fluid weights, is a standard in offshore oil and gas for testing cranes and rigs. The total weight was estimated at about 660,000 pounds, simulating the real lift of a Starship. What's brilliant: when empty, each bag weighs just a few hundred pounds, easy to move and reuse. Compared to casting solid iron blocks that weigh hundreds of tons, this method could save SpaceX millions of dollars. So here's a question for you. How do you view SpaceX's strategy of using what's available to develop cutting-edge tech, smart and resourceful, or risky and improvised? Let's return to the front lines, Roberts Road in Florida, where a full-blown infrastructure race is underway to catch up with Starbase. Thanks to satellite imagery from Umbra Space, we now have a clear view of the rapid day-by-day transformation taking place there. One of the most notable developments, the foundation for the new Gigabay, is already taking shape, and inside a large white tent construction is actively underway on the orbital launch pad. Florida is no longer trailing behind. It's now running neck and neck, maybe even shoulder to shoulder. Take a look at this helicopter photo captured by Max Evans of NSF. The launch structure rising at Roberts Road appears nearly identical to Pad B at Starbase, same design, same scale, same construction approach. If the Florida team can maintain this pace based on how the OLM was installed at Starbase last November, we can realistically expect the full launch setup at Pad 39A to be completed by October. What do you think will happen when both Starbase and Roberts Road are fully operational? Could we be on the brink of a full-scale Starship production revolution? Share your thoughts in the comments. At the current rate, one thing is clear: by the end of this year or early 2026, at the latest, Florida will officially become SpaceX's second Starship launch site in the U.S. A massive operational hub, tightly integrated with a giga-scale manufacturing facility, will unlock the ability to launch frequently throughout the year for cargo missions, satellite deployments, lunar exploration, and beyond. The journey to Mars is no longer just a far-fetched dream. It's being built, welded, and tested, one joint, one launch pad at a time, right here on American soil. Are you ready to be part of this journey? Tell us what you're most excited about for Starship's upcoming 9th flight. One of the brightest stars in SpaceX's tech arsenal, though not named Starship, is the Raptor 3 engine. Yes, take a moment to appreciate the stunningly minimalistic beauty of this machine. Raptor 3 isn't just an upgrade, it's the spearhead of SpaceX's next-generation propulsion strategy. The latest images from the McGregor test facility show SN-20 now positioned on the southern test stand. This is the heart that will power Block 3 versions of Starship and Super Heavy in the near future. Over the course of development, hundreds of Raptor 2 engines were produced. But now, all eyes are on how quickly Raptor 3s can roll off the line. Why? Because it outperforms across the board: thrust efficiency, cooling, and manufacturing speed. Remember Tory Bruno's skeptical reaction, the CEO of United Launch Alliance, when he first saw a photo of Raptor 3? Many couldn't believe a fully functional rocket engine could look that smooth, virtually no exposed pipes or wiring in sight. And that's exactly the point. Raptor 3 conceals its entire plumbing system inside the casing, creating a compact, ultra-clean, and arguably revolutionary design. But beneath that minimalist exterior lies an exceptionally powerful machine. Raptor 3 doesn't just generate higher combustion chamber pressure, it's also engineered with active cooling to reduce wear and tear, significantly improving reusability. That's a mission-critical factor for Starship's future interplanetary flights. Did you know increased chamber pressure also means extreme temperatures exceeding 6,000 degrees? Without ultra-fast regenerative cooling using circulating fuel, the combustion chamber would literally melt in seconds. But SpaceX has solved that challenge. Raptor 3 is also optimized for faster production, an essential element in the push to accelerate Block 3 flight tests at Starbase. Every new engine off the line brings SpaceX one step closer to the goal of making Starship as reusable as a commercial airplane. What do you think? At this pace of innovation, could they really hit 100 launches per year as they aim to? Raptor 3, not just sleek, but incredibly powerful. Remember the skeptical reaction from Tory Bruno, CEO of United Launch Alliance, when he first saw images of Raptor 3. Beneath its clean design is a machine of unmatched power. Raptor 3 doesn't just deliver more thrust, it's actively cooled to reduce erosion, a key to ensuring reusability on long-duration Starship missions beyond Earth. Test data from McGregor confirms it. Raptor 3 achieves peak thrust up to 582,000 pounds, force far surpassing Raptor 2's 510,000 pounds, a 14% jump in under 2 years of development. And it's not just stronger, it operates at a stable combustion chamber pressure of over 5,000 psi while keeping pipe temperatures safely under 900 degrees, showcasing superior thermal efficiency without compromising durability. Even more impressive assembly time per engine has been slashed to under 24 hours, thanks to a streamlined inline design that eliminates over 30% of piping and welds compared to Raptor 2. This isn't just a rocket engine, it's the blueprint for future mass production. Every test fire isn't just a roar, it's a declaration SpaceX is redefining what a next-generation rocket engine can be. From the most advanced engine on Earth to a nearly forgotten spacecraft. While we're building machines that would have been unimaginable 50 years ago, out on the fringe of the solar system, a long-lost signal has just returned from a spacecraft thought to have gone silent forever. NASA has achieved the unthinkable after nearly 40 years. Engineers have successfully reactivated the backup thrusters on Voyager 1, the farthest human-made object in space. These thrusters had been dormant for decades, assumed to be permanently inactive. But against all odds, they just responded to a command from Earth. Launched in 1977, Voyager 1 is now more than 15 billion miles from Earth, roughly 168 astronomical units away. For years, it's used tiny thrusters to keep its antenna pointed toward Earth. But in November 2023, the spacecraft suddenly stopped transmitting data, leading mission control to suspect a failure in its primary navigation system. The only option, reactivate a backup system from the 1980s. A new command written in an ancient machine language was programmed and sent from Earth. The signal took over 20 hours to arrive and another 20 hours for a reply. But then, success. The backup thrusters responded, Voyager reoriented itself, and for the first time in months, Earth received a clear signal again. Just imagine farther out than any satellite beyond the edge of the solar system, an aging spacecraft is still whispering back to us. This isn't just a technical triumph, it's a powerful reminder of human determination in space exploration. Voyager 1 is now stable again, and ready to continue collecting data from interstellar space. And the most incredible part, we're actively controlling a spacecraft beyond the solar system. It sounds like science fiction, but it's real. The commands weren't sent through a slick interface, didn't involve AI, and weren't automated. Just lines of raw code written nearly 50 years ago, traveling 15 billion miles through space, and answered by a faint pulse from a veteran explorer. Out where sunlight fades and Earth's signals barely reach, Voyager 1 is still listening. A tiny probe built with 1970s tech is quietly receiving our messages. While its scientific instruments aren't fully back online, yet the restoration of its thrusters is an incredibly promising sign. This extraordinary journey isn't over. Have you ever wondered if you could see the world from Voyager's perspective? Would your view of life change? Try expanding your perspective like Voyager. Dare to think bigger. Dare to rise above. Meanwhile, on the front lines of the private space industry, Relativity Space is demonstrating incredible momentum with its next-gen reusable rocket program, Terran-R. In March and April alone, the company completed nearly 30 critical design reviews for key components, pushing the overall design phase close to finalization. One major highlight, the vacuum-optimized second-stage engine, is moving swiftly into production. Large sub-assemblies are now in fabrication, and the first propellant tank for the first stage has been welded, inspected, and entered mechanical assembly. The dome structure's essential parts of the rocket's frame are being installed, and composite overwrapped pressure vessels, COPVs, have completed welding and are ready for integration. Most notably, engineers have just performed their first friction stir weld on actual hardware joining the common dome to the liquid oxygen tank. This marks a major milestone in building cryogenic tanks, a technology mastered by only a few nations and aerospace companies. Why choose this method over traditional arc welding? Because it guarantees airtight seals at cryogenic temperatures, a must for rockets designed for multiple reuses. In engine development, progress is just as rapid. The main combustion chamber is complete, the injector has passed its critical tests, and a prototype engine is being upgraded to serve as the second-stage vacuum version. The nozzle throat, vital for upper-stage efficiency, is now in production. Inside Relativity's Long Beach factory, new generation CNC machines and metal 3D printers are coming online. The company's propulsion campaign is nearing completion, with final engines soon headed to NASA's Stennis Space Center for hot fire testing. At the same time, the legendary test stand A2 at Stennis is undergoing a major upgrade. New pipes, pumps, and fluid systems are already being delivered. On the software side, the avionics and control teams have completed a full-scale hardware out-of-the-loop simulation, a ground-based test that's one step short of flight. As for structural tests, teams are preparing for full load evaluations as new test stands come online. Over at Cape Canaveral's LC-16, the horizontal integration facility is rapidly rising. Steel beams are climbing skyward, launch deck construction is expanding, everything is heading toward launch readiness. No pause, no holding pattern. Relativity is ramping up on all fronts. Engines, tanks, avionics integration, all converging toward a single goal. The first flight of Terran R becoming more real with every passing month. So here's the big question. Can a startup like Relativity truly compete with SpaceX, the established titan of the space industry? What do you think? Drop your thoughts in the comments. The first flight of Terran R, a fully reusable rocket, is currently slated for 2026. Meanwhile, over at NASA, the Artemis II mission, the first crewed return to lunar orbit in decades, is picking up steam. After delays caused by concerns about the heat shield on Artemis, the official launch window is now updated to February 2026 at the earliest. A major question looms: can this schedule hold when even a single test anomaly could delay the entire mission? Recently, the Artemis II crew completed emergency egress training at Launch Complex 39B, the same pad that hosted Apollo and Space Shuttle launches. Simultaneously, rocket assembly is entering a critical nerve connection phase. At NASA's Kennedy Space Center, engineers have just installed the Interim Cryogenic Propulsion Stage ICPS, the upper stage of the SLS rocket, into the core structure. This is the stage that will deliver the final push, sending the Orion spacecraft out of Earth's orbit and directly toward the Moon. Did you know the ICPS, Interim Cryogenic Propulsion Stage, uses the RL-10B2 engine, renowned for its exceptional reliability in the vacuum of space? With that, the launch vehicle is now fully assembled from the core stage, and the two solid rocket boosters, SRBs, to the ICPS, everything is mounted on Mobile Launcher 1. This is the tallest rocket NASA has built since Saturn V, and for the first time in decades, it stands tall, once more ready for its mission. But assembly is just the beginning. Next comes a series of integrated systems checks, where every component, from the rocket's onboard flight computers to the ground control panels in the Launch Control Center, must communicate seamlessly. Every function, every connection will be verified through simulated countdowns, all before Orion is attached. Speaking of Orion, just a few days ago, the spacecraft was moved from the Armstrong Operations and Checkout Building to the Propellant Loading Facility, a major milestone. Recall that concerns over Orion's heat shield were part of what delayed Artemis the Second. Now, each step in this process brings us closer to that iconic moment, a fully integrated vehicle standing on the launch pad, ready to carry humans back to the moon. Can you imagine that moment when the rocket engines ignite and flood the Cape Canaveral sky with light as the rocket roars to life and breaks free from Earth's gravity? Artemis 2 isn't just another milestone. It's a full-scale test of deep space human spaceflight, the kind we haven't attempted in nearly half a century. As it leaves Earth orbit and heads into cislunar space, the mission will test every aspect of Orion's systems: life support, navigation, communication, all under the harshest conditions humanity has ever faced. Here's something few people realize: temperatures in space near the moon can swing from 274 degrees to +248 degrees Celsius. That's a brutal test for every layer of thermal shielding, every circuit, every piece of hardware on board. So today's chapter in space exploration reaches a pause. But the story is far from over. The question is, are you ready to be part of the next generation of space explorers? Smash that subscribe button and turn on notifications so you won't miss a single cosmic secret waiting to be uncovered. Want to know what's coming next? Got questions about cutting-edge space technology? Don't hesitate, drop a comment below so we can dive in together. The universe is vast and waiting. The journey has only just begun. Space Now, where you're not just watching history, you're helping write it.